Hello, in this lesson, I'm going to go over a homework question that is StatCrunch number 2, also similar to your homework textbook problem number 51. This chapter 6.2, right? Suppose that the probability that a passenger will miss a flight is 0.0939. Airlines do not like flights with empty seats, but it's also not desirable to have overbooked flights because the passenger must be bumped from the flight. Suppose that an airplane has a seating capacity of 58 passengers, and we're going to do parts A through C. Before we start, let's understand the problem. So the probability that a passenger is going to show up for a flight is 0.9061, which get it from 1 minus 0.0939. And the probability a passenger do not show up is 0.0939 and have a seating capacity of 58. Okay, so write down the information. So A, if 60 tickets are sold, what is the probability that 59 or 60 passengers show up for the resulting flight in an overbooked flight? Okay, so let me write it down, the information. So we have 60 tickets, so N equals 60 tickets, 60. N is the number of tickets sold. So finding the probability of x is 59 or x is 60. That is equal to probability of x is 59 plus probability of x equal to 60. So since we're looking for probability exactly one event, therefore I'm going to use a binomial PDF. So we're going to do binomial. PDF of n in this case is 60. P, probability that passenger gonna show up is 0.9061, and we want to find a probability that exactly 59 show up, right? That would be the first one, and plus the probability of exactly 60. So that's binomial PDF n equal to 60. And the probability of show up 0.9061, and that one that is 60, right? So here just type both in your calculator, you'll get the answers. Let me show you how this is done, right? So in your calculator, go to second vars, go down the list, we're looking for binomial PDF. That will be this one. Enter. Now, the number of trial in this case here is 60, and the 60 seats. We're selling 60 tickets. And the probability of that a customer or passenger going to show up is this. And we want to find a probability of exactly 59. Okay, enter. Enter. And then we'll get the first one. All right, I'm going to do the second one. So second bars. All right, go down to the list again. And all the same, exact, only difference is 160 at this time. All right, now I'm going to add these two answers together. So I'm going to highlight it. Let me say this one. Enter. Plus the answer from the previous one, which is this one. That is approximately 0.01945. Right? Okay, so add it together, approximately 0.0195 in 4 decimal place. So the probability that 59 or 60 passenger are going to show up is approximately 1.9%, which is pretty low. All right, let's do part B. Part B asks, suppose that 64 tickets are sold, what is the probability that a passenger will have to bump? So this time there are 64 tickets sold. So n is equal to 64. And we want to find the probability. Let me find the probability of that a passenger been bumped. Right, that's what we're trying to find. Well, let's try to understand the problem. Okay, so we know that there are 58 seats available. So seats. So if I have number of passengers show up is between 1 to 58, then we're okay. So 1, 2, 3, all the way up to 58, there's no one gonna bump if 58 show up, right? But however, if I have 59 show up, 60 show up, 61 the passengers show up, 62, 63, 64 of them show up, then there will be a bump, right? So meaning that for any number that's more than 58, meaning 59 or higher, then there will be a bump, right? So 59 or more passengers show up, then there's a bump. Let me write it. So meaning that I want to find the probability of bump, maybe I want to find the probability of x is greater than or equal to 59. So we are looking for probability of x is greater than or equal to 59. Right? So I can find probability of 59 plus 6 probability of getting 60 plus probability of getting exactly 61 all the way 64 using PDF, or we can use the complement. Right, let's think about it. If I want a probability greater than or equal to 59, that's the same thing as saying 1 minus a probability of x less or equal to 58, right? A minus up to 58. So that is equal to 1 minus, well, less or equal to, we're using binomial CDF. That will be binomial CDF, sum up the less or equal to. And in this case, my n, number of tickets sold, is 64. Probability that a passenger gonna show up is 0.9061. And I want to find the probability of less or equal to 58. So x is 58. And type that in your calculator and solve. You get approximately, let me write it, 0.4361. Right? And let me show you how to do it in your calculator. Let me clear my window. Okay, so I want to find 1 minus CDF. So we second vars, go to binomial CDF. Enter. And number of trial in this case is 64. Probability that passenger gonna show up is 0.9061. And x is 58. Less or equal to 58. So enter. Notice that the 1 minus, so that is 0.34361. And that's how you do the answer for part B. And part C asks, for a plane with a seating capacity of 57, okay, how many tickets may be sold to keep the probability of bump under 5%? So the plane has a seating capacity of 57. And we want to find the number of tickets sold here to make sure that it's under 5%. So, okay, so we're going to find the probability of bump to make sure that it's under 5% or under 0.05. Well, x is the number of tickets sold. Let's kind of make a little table, right? So let's recall from the previous one, probability of bump, let me write it. Probability of bump is equal to 1 minus, let me explain. So if you have 57 seats, if you sell more than 57 tickets, or if more than 50 passengers show up, then there will be a bump. So I want to find a probability that more than 57, right? So meaning more than 57 show up, right? That means I want to find a probability that x is greater than or greater than equal to 58. Well, that is given by 1 minus probability of x less or equal to 57. Right? If more than 57 passengers show up, then there will be a bump. So we can basically plug it in for n, and let me make a little table. Literally trying some number. I have 57 seats. If I sold 58 tickets, let's say we sold 58 tickets, right? Probability of bump, meaning that the probability having more than 57 show up. right? So that would be, I want to find it, that's 1 minus probability of x less than or equal to 57. And that just binomial CDF. So 1 minus binomial CDF of n is 58. Let me use a different color, 58 here. 58, and again I'm changing the n here, varying n, depending on what the n, I'm looking for n. And my probability of showing up, let me do that, is 0.9061. I want it less than or equal to 57, okay? So I'm going to find the probability. So time your calculator, 1 minus binomial CDF of 58, comma, 0.9061 and 57. You'll get the answers of 0.0033. This one is still under 5%. Well, we'll see if I get 59, still get under 5%. My goal is find an n such that this will be under 5% or 0.05, right? So what if I change it to 59, right? So meaning that if I sell 59 tickets, the probability of being bombed is equal to 1 minus binomial CDF changing the 58 to 59. So this is the second one will be, if you write it down, you'll get a probability of 0.0212. Let me write it down. So we'll get a probability of 0.0212. Note that I'm just changing try different n here. And until I find one that is the biggest number that's under 5%. And still that 0.0212 is still under 5%. I mean, I'm going to try one more. So let's try 60. So if I try 60, notice that I get 0.0707. Notice that 58 is under 5%. 59 tickets, we sell 59 tickets, still under 5%. But if you sell 60 tickets, then it's really more than 5%. So probability of bomb here under 5% is n equal to 59. So n equal to 59 is the answer. So if we have sitting capacity of 57, and the probability of bomb under 5% will be, you could sell 59 tickets. So that the probability of bomb will be under 5%. So n equal to 59 is the answer. Right. So for this type of problem here, be careful with the wording. I think the wording part is the one that usually make it confusing. So I will say read the question many times, write down the information, and then before you proceed to the problem. All right. Thank you for watching the video. I'll see you next time.